Question. A registered electrical wireman installed an electrical wiring for 13 ampere circuit outbound socket with 4 mm square cable, MCB of 60 ampere level of overcurrent protection in a shop house with single phase supply entry. Did the electrical wireman make any mistake? If there is an error, please recommend a correct method and explain any relevant electrical regulations related. What we will look into: what is the fault and how to correct it, what number of regulation related, and what is the next action in order to prevent this from happening to our society and environment if related. The Electricity Regulations of 1994. The Energy Commission was created under the Energy Commission Act of 2001 as the new regulator for the energy industry in Peninsular Malaysia and Sabah. The Commission was established to ensure that the energy industry is developed in an efficient manner so that Malaysia is ready to meet the new challenges of globalization and liberalization, particularly in the energy supply industry. The Commission regulates and promotes all matters relating to the electricity and gas supply industry within the scope of applicable legislation, namely Electricity Supply Act of 1990, License Supply Regulation of 1990, Gas Supply Act of 1993, Electricity Regulation of 1994, and Gas Supply Regulation of 1997. Looking back at the question, a registered electrical wireman installed an electrical wiring for 130 ampere circuit outbound socket with a 4 mm square cable with value MCB of 60 ampere level of overcurrent protection in a shop house with single phase supply entry. Now, what is the fault and how to correct it? The answer is the cable. The 4.0 mm square cable. Now, we have the 4.0 mm square cable. From page 24 of the guidelines, we get this: the minimum cross-sectional areas of conductors based on their applications. For 13 ampere circuit outlet circuit, we use the 2.5 mm square cable, and that is the correct size. Based on the questions, there are some number of regulations related. Regulation 2, Interpretation, Regulation 11, Approval for commencement of wiring, Regulation 15, Apparatus Conductor Accessory, and Regulation 50, Eligibility to become wireman. But what we want to focus on is Regulation 15. Any apparatus, conductor, or accessory for the purpose of connection to an installation shall be sufficient in size, power, and number to serve the purpose for which it is intended, and shall be constructed, installed, arranged, protected, worked, and maintained in such a manner as to prevent danger. Do an electrical inventory. Figuring out where the power comes from and where it is going to be used makes it easier to frame the parameters for the job. Careful consideration of electrical loads and any requirements for protections and automatic voltage regulation are also great to think about at this point. Check codes and permits. Check out local codes and pull permits as they set standards for everything from how many outlets they'll be put in each room to what kind of wire they'll be used. Watch out for existing infrastructure. Part of avoiding damage is making sure nobody punches hole in plumbing or existing wiring. Live by the words ask twice, drill once to be on safer side. Cleanup and restoration. If dealing with the damage done by rewiring, make cleanup and restoration as early as possible. Aim for home runs for key areas and appliances. These are when a wire runs directly from a circuit breaker to an outlet with no other devices on that breaker, thus reducing loads on the power system and keep popped breakers to a minimum, creating a balanced system. Make sure the power is off. Make sure the power is always off before starting any electrical work, and if possible, make sure everyone in the area knows it is turned off for a reason. It may seem logical, but it's critical. Wear safety glasses and protective clothing. Covering the eyes is a must when dealing with electricity to avoid sparks or other debris to get in. Have the right tools on hand. Having the right tools for wire installation is important. Some tools include a voltage tester, wire cutters, wire and cable strippers, needle nose pliers, continuity tester, and others. Check with electrician. It is best to have trusted professional electrician do any electrical project. But if self-handling, follow all safety precautions from the beginning to an end of project to help ensure the safety of oneself, society, and environment.